Thank you for showing up on a Friday afternoon. I am really anxious because I am one of the very few things standing between you guys and your weekend. Uh, the only good thing is the weather is supposed to be crappy this weekend, so hopefully you're not all gonna head towards the door. Um, but yeah, I've got a tough challenge in front of me because I've got to be informative and entertaining at 3 p.m., 3:20 p.m. on a Friday afternoon. So that is not an easy feat, but I have come prepared. So I'm going to cheat in order to keep you guys engaged and motivated and paying attention, and more importantly, asking questions. Because I don't want to sit up here and deliver an hour-long monologue. So in order to incentivize audience participation, I have brought candy. Uh, yes, it's not the variety I usually pick up because I was really swamped at work this week. So this is from our neighbors at Lidl, but hopefully it's good. They're Belgian chocolates. You'll have to tell me. Um, and there's not that many of you, and there's a lot of candy. So you have excellent chances of claiming the candy. And the way we distribute the candy is you ask a question. It has to be related to the topic of the presentation. Because a few years ago, I had a smartass in the front row. Hey, can I get a box of candy? And technically that was a question, so I had to give him a box. But I'm doing my own bit of AI here, so I'm learning from my mistakes. So I'm clearly setting out the rules at the very beginning of the session. So just put up your hand at any point during the session, ask a question, at least remotely related to AI, ML, data cleanup, whatever you want. I'll do my best to answer it, and then you get a box of candy. And in addition to the candy, I raided the UiPath goodie closet this morning, and I brought this. Now, this is the welcome gift we give to our new colleagues in Cluj. It is a cool backpack made by OGO, and it is full with all sorts of branded swag. There's a Moleskine notebook in there, and water bottles, and I don't know what else. I haven't even opened mine. But the way we're going to hand this out is I get to decide who asked the best question. And at the end, we'll hand this out, and that'll be it. So this is your motivation, in addition to the know-how and expertise I will hopefully impart today, to stick around and participate. Now, last thing, last sort of housekeeping thing I want to mention is sort of my motivation for doing this session and for becoming involved in the sort of developer community and speaking at events like this, because I'm not sure if you guys know or not, but the speakers that come here don't get paid. You know, some of them have consulting businesses and they get work through that. For better or worse, I don't. I have a full-time job, so that's not really an incentive for me. If you ask my wife, she says I do it because I love to hear myself talk, which may or may not be true. I do love to hear myself talk. But my motivation is because I've been privileged and lucky enough to have jobs over the past sort of decade or so that have allowed me to spend a fair bit of my time doing research, understanding technology, understanding trends, figuring out if they're going to be successful or not. And sometimes I'm good at it. Sometimes I'm not. If you, for example, if you Google my name, I think on the second or third page, there's going to be a recording of a panel discussion from 7 or 8 years ago, where the topic of the panel was the future of the web. Is it going to be HTML5? Is it going to be Silverlight? Or is it going to be Adobe Air, I think was their technology back then. And I was talking about Silverlight. And I was extolling its virtues. And look, it's not frame-based like this Adobe crap. It is what is it, time-based, and it's managed code. And why would you want to write JavaScript? There's not many. Turned out I wasn't quite right on that one. And there are some pieces of software out there that probably had to get rewritten about 2 or 3 years ago in Angular or React or something like that. But the way I choose to look at it is I was creating job security for myself, right? So that you just rewrite the same software every few years. But yeah, so my motivation is to impart my expertise because I think it's important for us as an industry to write good software. Software runs the world these days. Everything, including the espresso machine in the UiPath offices is running software. It's got a touch screen. It's running some sort of Linux. it freezes every once in a while, and we have to reboot our espresso machine. And when it starts up, it has a console-like display, and it says mounting file system. I'm really frustrated when I see that thing, because the only thing an espresso machine is supposed to mount is coffee, not a file system. So yeah, I think we have a shared responsibility as software professionals to write good code and to produce technologies that is secure, that is scalable, that is robust, and all that good stuff, and all of those sort of non-functional requirements. So my name is Silviu Niculita. I am currently the engineering manager for the UiPath office here in Cluj. We're always recruiting good Microsoft Stack engineers, so if you're in the audience, hit me up after the end of the session. I'm also a Microsoft MVP, which is something that happens to you if you do enough public speaking, and if your public speaking tends to be around Microsoft technologies. But I like to think that I'm a fairly objective judge of technology. So, for example, if AWS has a better offering in a particular space, or Google does something better, I will come out and tell you. Just because, again, the MVP is not a paid position. You just get preferential access to the product teams, and you get to know about what's going to be announced, for example, or at Ignite or at Build a few months ahead of time, which is useful sometimes. And you've got my email address up there, just in case you guys want to ask questions that don't lend themselves to a public forum. Feel free to reach out to me. Now, what are we going to touch upon today? So we're going to talk about why machine learning is interesting. You're in this session, so hopefully this is an area of at least of interest for you. So we're going to talk about some of the sort of productive use cases for machine learning. We're going to talk about why automating machine learning makes sense, and why people have invested fairly in researching ways of accelerating the development of machine learning models. We're going to talk about what types of machine learning scenarios can be accelerated and augmented through the use of automation. We're going to have a demo on top of Azure and their brand new, what are they calling it these days, Azure ML service. I keep calling it Studio. Studio was the old name, now they're calling it service. And at the end there, we're going to try to draw some conclusions. There's going to be a call to action. And at the very end, questions and answers and candy. Good. Now, why machine learning? Well, even if we realize it or not, we are surrounded by it, right? Chatbots are everywhere. Most folks have one of those silly speakers. We have them whether we want them or not. Samsung makes that stupid thing called Bixby. That is their pathetic attempt at producing machine learning and artificial intelligence. So we are surrounded by implementations of machine learning, whether we realize it or not, right? It's everywhere in retail and manufacturing, predicting maintenance, figuring out when a particular component on an elevator is going to break before it actually breaks. Marketing, legal, finance, even RPA, right? So UiPath works in the field of RPA, and the way we're using machine learning is in the area of document understanding, right? So you give us a huge PDF, and we look at it, and we try to understand, okay, so from page 1 to page 5, it's a contract. From page, the next 20 pages are receipts, and then the next one is a contract again, and extracting all sorts of interesting information from those documents. Another spot where we're using it is, RPA entails a lot of UI automation, and a lot of large enterprises have, synthetic desktops, right? So you're actually remoting into some sort of VDI infrastructure, virtualized desktop. And doing UI automation is really tough because you don't have access to the DOM, right? You can't select a button. So we use computer vision there. So we take a screenshot of your application, we shoot it off to a self-built computer vision model, which is really good at identifying, oh, so this is a text box, this is a button, this is a tab control, and that sort of thing. So those are some of the ways we're using AI, ML within UiPath, for example. So it really is everywhere. Facebook, for better or worse, is a huge machine learning model, and we are the subjects, right? So we are constantly feeding in information, we're giving it inputs by liking stuff and poking people and doing all sorts of stuff. And it's training a model that is suited towards figuring out what sort of content we are going to engage with, because if we engage with more content, we spend more time in the application, they make more money from advertising, from Russians. So, you know, make of that what you will. And obviously self-driving and all that good stuff. But yeah, these are just some examples of unusual uses of artificial intelligence and machine learning I've come across over the past year or so. You guys know who Taylor Swift is, right? She's some sort of pop singer. That was a question or an answer? Yeah. Yeah. So far we have not, sort of, right? So we do not, so UiPath currently, so the question was if the computer vision model we've built for user interface understanding is productized, as a service that anybody can integrate. Not currently. I'd have to ask the folks in Bucharest that built it if they have any plans in that area. You could technically use it because our software is the community edition is free. So if your organization has revenues under $5 million, you can use UiPath for free. So there's an activity, and you can use it that way. But in terms of calling it, giving it your own screenshot, and getting back the recognition results, I don't think we offer that currently. But if you've got a use case, let me know. Right. So going back to Taylor Swift, in one of her concerts, they set up a set of cameras, and whenever somebody would sort of stop and hover in a particular area, they would take a photo of that person, and they would check it using facial recognition with a database of Taylor Swift stalkers. And so those folks would presumably get yanked out of the arena if they showed up. So it's a very unusual use case. I'm not sure how comfortable I would be if showing up at a concert and a bunch of different services doing facial recognition on me. But it's it's already happening, right? Microsoft built something that is designed to help sports teams identify when certain athletes are in danger of becoming injured, right? Based on their past performance and all sorts of other inputs, they try to figure out, well, maybe you should let that guy sit this one out. Otherwise, they ran the risk of becoming injured and becoming unavailable for whatever the final and that sort of thing. So that's a really interesting one as well. Medical, right? IBM has a huge division, and they've made a bunch of money from their service called Watson in terms of augmenting and sometimes even replacing doctors in the medical diagnosis process, right? So there already exist models out there that exceed the accuracy of trained physicians in terms of diagnosing certain medical conditions. And this is just an example of a startup that's making it really cheap, right? Now compare it to us. In order to go see a doctor in the private medical system is what, $40? You can get sort of your CAT scan interpreted by the equivalent of a world-class physician for $1, right? So this is really powerful stuff, and I think it's really going to have a big impact on our ability to deliver medical services in remote places, and because this is infinitely scalable, right? And I think it's going to have a big impact on society, so I'm really excited about this development. And this one is something I actually added just now. So Stanford built this thing. And what they're able to do is, if they've got a recording of your head and you're saying something, they've built a piece of software which, through AI and ML, enables them to change what it looks like you're saying. And this is a demo of it. Let's see if the YouTube video will work.
User study. We asked users to rate the realism of source videos, which we want to edit.
The dingo ate your baby.
Real reference videos where the subjects speak the edited sentences.
The dingo ate my baby.
And edited videos obtained using our approach.
The dingo ate my baby.
She sells seashells by the seashore. She sells ice cream by the seashore. She sells ice cream by the seashore.
Whoops. Right, so that was,
Our results were
whoops.
considered realistic by more than half of the
Uh,
participants.
Oh, there we go. So that was interesting, right? So this,
Thank you for watching.
there we go. So the one on the left-hand side was the target, so the one that they edited. The one in the middle was the guy actually saying the edited text, and the one on the right-hand side was their concoction, right? And it fooled more than half the people. So this is, just give them 3 to 4 years, and welcome to a very, very interesting world of fake news, where you can make anybody look like they're saying anything, right? So this is going to have really, really interesting ramifications, right? Sometimes some of this research you sort of wish they wouldn't really be doing, but you know, it is what it is. And this is something that's really interesting, right? So in order to produce a machine learning model, you need data, right? Here's a picture. Does this picture contain a hot dog or not? And you need a human being to label that, to create a trained model that will, to a trained data set that you can actually use then to train your model so that it can create predictions. And it seems that in Finland, they're using prison labor to do that. So instead of them, I don't know, doing road construction, you know, they're training AI. So that's a bit of a twist there. You know, you wind up in jail, and they sit you in front of a computer, and you're tediously saying yes, hot dog, no. Okay. So that's it in terms of machine learning. Now, why do we need to prefix machine learning with automation? Well, this is a typical machine learning workflow, right? So you've identified a business problem that you're trying to solve. For example, you have a website that allows you to post car ads, right? You're trying to sell your second-hand car, and you're offering a website that does this. And you're trying to add a service which will allow your users to get an estimate of what the fair market value for their second-hand car is, right? So that would be a good problem statement, right? And you want to do that, that's just basically a linear regression machine learning algorithm. So you've defined your problem. You pull your data, right? Presumably you have access to a database of ads for cars. You have a bunch of car attributes. You have the sale. You have the requested price. Obviously, you would want to have the actual sale price because cars sometimes sell for lower than what the guy is asking for them. But you know, you'll have to do with what you're going to do. Then you have to develop your model through iterations. And if you zoom into this guy, you have to define your target metric, extract derived features, select features, fit the model. Somewhere in here, you have to identify the appropriate algorithm and the hyperparameter values, and then you evaluate it, and then you go back and back and back and back and back until you have a model that produces an accuracy level that you're happy with. And then you deploy it, you monitor its performance, and then you start all over again, right? Because it's sort of a treadmill type exercise where it's never done. And this is very resource intensive, right? And it is very time consuming, right? So the current approach doesn't really scale well. And the reason for that is there are simply not enough data scientists out there, right? So a research company says there's about 22,000 people that have the correct skills to work in this industry, and the demand is several hundred thousand, right? So labor shortage, right? Which is a good reason for us to get into this industry, and I'm happy to see at least a few folks attend this session, right? Also, the folks that do exist cost an arm and a leg, right? So this is a screenshot from the New York Times. $300,000 to $500,000 in the appropriate geographies in the United States is not an absurd amount. The data scientists that work for UiPath in Bucharest, for example, are also extremely well paid. So, you know, if you're considering a career shift, maybe you want to consider this, right? So, okay, it's tough. It pays well, but how do you actually factor in automation into this? Well, going back to the example I mentioned earlier, right? How much is this particular car worth? How would you go about doing it using sort of the traditional means? Well, you have to identify which features impact your prediction, which algorithm you should use, and which values, which settings you should set on that For example, the number of hidden layers in a neural network algorithm, that sort of thing. All of these machine learning algorithms have a bunch of properties that you have to specify in advance before you actually run the training portion of it, right? So when you go to cars, you have stuff like mileage, condition, what brand it is. Obviously, a BMW is going to have a different price from a Ford, which is going to have a different price from a Dacia. You know, how old it is, if it is, you know, compliant with certain pollution norms, all that good stuff. Which algorithm, and there's dozens and dozens of these things out there, and each one of them has different parameters that you need to set in order to extract the, you know, an accurate result. So you would pick some attributes or features, you would pick one algorithm, you would, so these for a gradient boosted tree, these are the most relevant properties. You would specify, you just figure something out, and you would get something that is 30% accurate, which sucks, right? You go back to the beginning, you add condition, try a different one, try different properties, 50%, or it's getting better. And you do this a bunch, and eventually you find one that is 95% accurate. Great success, but weeks have gone by of tedious work. So that is obviously less than ideal. Now there are cheat sheets out there, right? So this is one that's put out by Microsoft, and you start at the beginning, and then depending on what sort of you know, problem you're trying to solve, it will tell you which one might be best suited, but it's still sort of an NP complete type problem where you have to try everything before you find the optimal result. So it's still tough. Now, how does automation actually play into this thing? Well, it's not a really a, it's a gray box, it's not a black box. So you have your input, which is your data, right? The training set of, you know, cars and their characteristics and their sale price. You define your goals. So I want a model that is at least 90% accurate, and you apply some constraints, right? I can afford to try to throw, I don't know, 50 compute hours at this, you know, on a cluster that has 10 virtual machines that are yay big, because you know beforehand how much that's going to cost you. You can say, I want you to stop if you find a model that is above 90% accuracy. I mean, you have a few other attribute constraints that you can specify that will stop it, right? And then the framework behind this whole thing will try a bunch of different algorithms and parameter values in parallel. It's pretty intelligent about doing this, right? So there's machine learning behind the machine learning, automated machine learning, if you will. It will find one that satisfies your requirements, or it will give you the best one when it times out. So if you tell it 50 hours, after 50 hours, it'll show you the leaderboard, and you can take the most successful one and extract it as a, I think it's a pickle file, which is just a serialized Python binary, and you're off to the races, and you can deploy it either in Azure or in your own virtual machines. You can do whatever you want with it, right? So that is, in a nutshell, you know, the 10,000-foot view of how automated machine learning works, right? In terms of how Microsoft stuff works, right, it currently supports just two scenarios, classification and regression. So classification is putting stuff in a bucket, and regression is identifying a value, right? Guessing the price would be a regression problem. Right, it integrates with Azure Machine Learning, Jupyter Notebooks, all that good stuff. It currently only supports rectangular data. So the input needs to be a CSV. It doesn't do anything with images yet. Audio, none of the stuff is currently supported, although you can anticipate that it will be added. There's a Python SDK if you don't want to use the visual UI. My demo will be using the visual UI simply because my Python skills suck. And it's really transparent. You can view the run history. You can see the models. You can see all of the models that were tried out, the successful ones, the unsuccessful ones. It is really easy to scale training across the cloud. I will show you. You simply define a compute cluster, and you can have as many or as few VM instances as you want, and it will automatically parallelize your training activity on top of that cluster. And in terms of that intelligence I mentioned earlier, where it's smart enough to figure out based on sort of the shape of the data you gave it, and for example, the cardinality of a particular feature. For example, if you give it a feature that has a bunch of distinct data, distinctive values, that's not going to really be useful for machine learning, right? So it's smart enough to, maybe I don't want to use this one, right? And Microsoft never sees the data you fed into it in order to train the model. It only sees basically the schema and the aggregate counts of all of your fields. So in terms of privacy, that's also a plus. Okay, now let's see this thing in action. And questions? Yes? Yes. You get a predefined set. So, and you're going to see the list of the stuff it's gonna try, and it also does. So at the very end, it does something. I forget what it's called, but essentially, it's quorum mechanism. I forget. For example, if you have three models, they get a vote, and if two say one thing and one says another thing, it'll go with the majority. It's called majority quorum, I believe. Anyway, it's going to be part of the demo. So who's used Azure here? Just so I know. Okay, a few folks. So this is, let me go back home here. So this is the Azure portal, right? And this is where you go to provision stuff on the cloud. And you can create storage accounts here. So it's blob storage. You can create virtual machines. You can create managed Kubernetes clusters, anything your heart desires. And if you wanted to get started, what you would do is go into the where is AI and machine learning, and you would create something called a machine learning service workspace, right? And this encompasses everything you need in order to do ML. And this is probably going to take too long for me to do on the spot, but let's give it a chance. Let's see, ITCamp space, just a subscription. I have a couple, but you're probably going to have just the one. And you're going to stick them in a resource group. And a resource group is just sort of a folder structure that allows you to logically group the stuff you create. If you create something and you leave it running, obviously it's going to cost you money. So the way and I have had instances where I left, a conference presentation and I'd used up hundreds of euros of Azure credits. So in order to keep that from happening, I try to group everything into a specific resource group and delete it after I'm done. And you get to define which region you want this workspace to be provisioned in. And we're going to go with Northern Europe. Going to review. Yeah, it validates everything, and then we hit create, and it's going to go ahead and do its thing. But and this might take a few minutes. So just because I don't want us to sit around here and wait, I'm going to switch to one that I created beforehand. So in ITCamp 19, there is an SNML service, and let's see what we have in here. So we have compute, right? So when you're training your model, it needs to run on something. And these are just virtual machines, or rather sets of virtual machines, and I have two clusters, right? One is made up of, let's see, let's do an edit. One is made up of DS1_v2 virtual machines, and it lives in Western Europe, and it has a minimum of one node, so I want to keep at least one open because it does take a while for them to spin up. It will scale up as high as 3, and if they don't get any action for 120 seconds, it kills them, right? So I'm using 3, and then it goes back, and there's no, they go on idle, it kills 2 of them. And I can actually dynamically scale this thing out. And I'm going to go 5, and it's going to start doing its thing. But currently, there's no running work on them, so there's just the one, and it's currently idle. And I also have, for example, another one, which is an extra large one, which I created more recently. Again, it's and this one is using bigger virtual machines. These are D13s that have, I think, 4 or 6 cores and like 50 gigabytes of RAM. So these are larger virtual machines. Oh, and it actually finished provisioning my other workspace. Now, another item of interest here is the virtual interface. As I said, my Python skills suck, so I'm not going to go in there, but I'm going to use the UI. And has anybody here seen Azure ML Studio? Okay, so a few folks. Now what this guy allows you to do is to create and train machine learning models just by using a visual interface, and it's really powerful. Now this technically is something different. It's the machine learning service, and the studio is going to get deprecated, but they're still really, really similar. So what I have in here is something I created a couple of a while ago, and I'm not going to, just because a few folks have seen it, I'm not going to recreate it from scratch. But this is very similar to SQL Server Integration Services, for example, or any sort of ETL package, ETL tool that you might have used, right? So I have an input, which is just a CSV file, and I think I can actually download it and show it to you, right? So this is just, and it's one of the samples you've seen here, right? So I've been doing demos with this thing for 4 years now. So this thing came out in 2014 or 2015. So this is just an extract from the US Census, and it has, people's age, their working class, their level of education, their marital status, their occupation, race, gender, how many hours per week they work, native country, right, so their country of origin, and their income. And their income is sort of a binary classification, so people either make less than or equal to $50,000 a year or more than $50,000 a year, right? So I'm sure quite a few of you have seen this. The other really popular one is the Titanic data set, which has all of the list of all of the passengers on the Titanic and whether they made it or not. And a really popular one is to try to figure out if you had been on the Titanic, would you have survived or not based on your characteristics, right? And what this allows you to do is obviously some sort of data manipulation, right? So in this particular case, what I'm doing is, hold on, edit. What I'm doing here is I am removing my redundant columns. So columns that I don't need, I'm just throwing away. And then I'm going to split my data, right? So I'm going to keep 70% of my data to train my model, and then I'm going to evaluate it with 30%. And that just means that, out of 100 records, 70% are going to flow through here, 30 are going to flow through here. I have a machine learning algorithm, right? A two-class boosted decision tree, which has a bunch of parameters, right? So these are called hyperparameters because you have to specify them ahead of training. And I'm with my 70% of the data, with this algorithm, I'm training a model, I am then scoring it, right? So I'm comparing, I've got the guess from my model and the actual correct value on the data set. And this, I actually ran this guy ahead of time, and I could actually see the results. And, right, so it ran on 9,768 rows. And this is the value in the input file, and this is what my machine learning model guessed. And for the most part, you see that it did a pretty good job. Let's see, oh, it made a mistake on this one, right? So this Irish guy, it said that he or she's gonna make less than 50,000, and the guy actually makes more than 50,000, right? But you don't have to go in and compare line by line. We have a really nifty evaluate model component, which just gives you a nice visual representation of the accuracy, right? So the left-hand model had an accuracy of 0.84, right? And accuracy is just, I forget what it is, true positives plus false negatives divided by, I don't remember the formula, right? But there's a few metrics out there that you can use to identify the accuracy of a model. In this case, it guessed correctly, let's say 84% of the time. Something that is above 90% would be extremely good. If you've got above 95%, something's probably wrong because you're overfitting your model, but that's a whole different discussion there. And what I did here is I have one algorithm here, a two-class boosted decision tree, and a two-class average perceptron. The perceptron is one of the oldest algorithms out there. I think it was developed in the 70s, and this visual interface has a nice way of comparing them. So obviously, as you can see through this visual representation as well, the left-hand one did much better than the right-hand one. This one has an accuracy of under 80%, right? So 0.795. Now this is how you would do it manually, right? it's a sort of like a soccer competition, right? The guy that won the last match stays on the field. You bring in a new one, they duke it out. This one goes out, bring in a new one. Maybe you switch the maximum number of iterations. Maybe you specify a different value for the other one, and you go around and around and around until you find one that's suitably accurate, right? That is obviously very time-consuming. So where the interesting stuff happens is here. Automated machine learning. So what this allows you to do is, and it's done. I actually started one before we started. We will create an experiment, and we will pick awesome demo one, I believe is the one. I will pick the big compute cluster. So it goes quickly. It will look through my blob storage accounts. It will find the fact that I uploaded the CSV that I showed you guys a few minutes ago, and it allows me to pick which columns I want to feed in there. So age stays, working class stays. This one I don't need. Education, no. The occupation, yes. Race, unfortunately, is relevant. Gender is relevant, unfortunately, again. These are not relevant. Hours per week, yeah, they're probably going to have an impact on your income. Native country as well, and income is going to be included. I need to tell it what sort of prediction task I'm telling it to do, right? So the fact that it is a classification problem. So I need it to tell me if people make more or less than. So this is the simplest thing you can do, binary classification. You have just two buckets. And then the target column is obviously income. Although you could do it the other way around, based on people's income, try to guess their age, right, which will be a more multiple class classification problem at that point. And to the gentleman that asked me about algorithms, you can't really give it additional ones. Oh, and the primary, the metric is in here, right? So I wanted to pick the winner to rank them based on the accuracy. I wanted to work for 60 minutes. Maximum number of iterations 25. The threshold, right? If it reaches an accuracy above a particular threshold, it can stop. Bunch of other stuff. And I can't give it my own custom algorithm yet, but I can blacklist some. So for example, if I'm really sure that, I don't know, gradient boosting isn't really applicable, check it, and it won't try it at all, right? So that will sort of reduce the number of algorithms it'll try so that it spends more time working on the ones that are really relevant. So I hit start, and it's going to start doing its thing eventually. Right. I started one, 90 minutes ago, and I think 90 minutes have passed, so it's finished. I wanted to have one that was in the middle of doing its thing, because this has a bit of ramp-up time. It's going into a preparing state. Right, so this is the one that I started at 2:49 p.m. and it's 3:50. I guess it's finished earlier. So it's going to go into preparing state, but let me show you a completed one, right? So this is the one that finished. And this is just a visual representation of the accuracy results of all of the algorithms that are tried across a bunch of different iterations. And the most successful one is this one, 0.8453 blah, blah, blah accuracy, which is pretty good. And it is something called a voting ensemble, right? So voting ensemble is the one I was struggling to describe earlier, where it picks several algorithms and it lets them vote. And essentially, it's a majority rule type setup, right, where it's relying sort of on the wisdom of the masses to produce slightly better accuracy than just relying on one. And you can see the lowest one it produced was around 71%, which is pretty bad. But then it slowly got to where it's pretty good, and I can see the accuracy here. So this is the leaderboard. It took it 1 minute and 26 seconds to actually train and evaluate this guy, and actually I can grab my model, which, as I said, is a pickle file, which is a Java, which is a serialized Python artifact, and I can take it and I can either deploy it within some Azure compute, or I can take it and run it on premises. I can do whatever I want with it. And if we go back to the one we just started, it's still preparing. But if you look at the compute, for example, It should. So I think I told it to run on the XL cluster. It is. So one of them is running, and as it picks up steam, you'll see it, spin up. This cluster is going to go into, I think they refer to it as a scaling state, where it's spinning up to additional nodes, and it's going to start running experiments on that one as well, on the new ones as well. So it's really fun to follow along and see how it does through the telemetry mechanism. Yes. Yes, yeah, so they have GPU instances, GPU optimized instances, and I think FPGAs as well. So yes, so, I mean, let me show you actually. I go to add compute, I give it some cluster and compute type. Obviously I can pick any something other than machine learning compute, but let's go with this, Western Europe. And I'm going to choose a machine learning size, and this is the whole list of sort of the machine, the VM types that are supported. And if we go to Azure ML service pricing, I think this page has a nice table of. There we go. So you've got general purposes, compute optimized, memory optimized, storage optimized, GPU, because I don't know them by heart. Right, so the NC ones are apparently GPU optimized ones. So yes, it does support that. And you have FPGAs here as well, which are free. Awesome. So there you go. Yeah, it's in preview, so it's free. So knock yourself out. So I'm sorry, no second box of candy for you. And for example, if this one ran already by, for example, I can tell it to, there you go, come on, run on the other cluster. And this is the nice thing about the ML service as opposed to the ML Studio. When it came to the ML Studio, your compute ran on some sort of compute layer that you didn't really understand. It was a black box. In this case, your experiments here run on compute that you manage, and you can scale out or scale back in to your heart's content. And if we go back to, let's see if how the experiment is doing. Automated machine learning. Boom, boom, boom. Oh, and it's running, so we can see it in real time. And it's done a couple of them, right? So it's the best one we have right now is 0.83. So it's still already pretty good. So the one we built by hand was 80 some plus change. So it's getting pretty good. And as it, so you're seeing it, right? So it tried a couple of things, and it's going to keep going and keep going. This guy is going to keep updating. Let's refresh it here by on demand. Oh, it's. No, still that one. It found one that's worse. But yeah, every couple of minutes it's going to populate with more experiment results, and it's going to go, keep at it for quite a while. Okay. Questions so far? Oh, excellent. Quite a few. Yes. No, not really. I mean, it's, well, it depends, right? So I'm not a true data scientist. I know enough about it to be dangerous. So if you're a real practitioner, maybe. It has taught me stuff, right? I didn't know about voting ensembles until I saw it produce one as the winning algorithm, and I was like, what the heck is that? And I had to go out and read it. So I have learned stuff from it, but not at a level of, given this data set, my gut feeling is, the average perceptron is going to kick ass, but it's actually a boosted decision tree. So I'm not that good of a data scientist, unfortunately, and my gut feeling sucks. That's why I need stuff like this. That's why we need stuff like this. But yeah, good question. And I saw a few more at the back. Yes? How does it compare with other tools? There's a slide on that, so I'm going to show you. So there's a few. Microsoft doesn't have a monopoly in this space. In sort of this, in the machine learning industry, there's a lot of, what they say, imitation is the most sincere form of admiration. So everybody admires the hell out of everybody else, right? So there's a lot of competing frameworks out there. And Microsoft, well, I'll show you the Gartner chart and everything. So there's information about the competitive space here as well. Yeah. So the question is around retraining the model, right? So going back to the process where I showed where you have to go back and then retrain it based on new data, based on new learnings. Not currently. So what's funny is, but you can very safely anticipate that that is going to be added in. For example, when Microsoft came out with ML Studio in 2014 or 2015, it didn't have that capability. And then I think 1 or 2 years later, they added it in where you could programmatically retrain your model based on a new data set. So you can safely assume that they're going to add this into the product, but it doesn't currently support that. You have to go back in and kick off AutoML all over again. But it's not that painful. You can sort of automate it yourself by keeping at it. You can sort of automate it itself, but you'd have to write your own sort of scripts and use the Python SDK to do that. But the visual side of it doesn't really have that yet. If we go back to the compute, let's see what they're doing. So compute, the clusters are, okay, let's see. Oh, so there you go. So it is already, right, so it's running on 2 nodes already, and it's preparing a 3rd one. So you can see that, the scaling mechanism works. Yes, any other questions? Okay, back there. It does that on its own, actually. So it's smart enough to do a certain level of that. It is smart enough for the example I gave you earlier. For example, if there's a high cardinality on a feature, it will drop it on its own. It's smart enough to produce, under certain conditions, synthetic features. It's smart enough to figure out, so it looks like you're trying to give me a datetime, and it's smart enough to figure that out if you're trying to do time-based regressions. So to a certain extent, yes, but you can't really influence that side of it. So if you want to do some of that, you're probably better off just doing that ahead of time and giving it the CSV with the features you'd want to be interested in. So sort of is the answer to that question. Yes, and I think I saw another hand go. Yes. You can tell it when to stop, right? So, I found one that's in this level of accuracy. Okay, I'm done. Well, that's up to you to decide, right? If your training data is not diverse enough, you're going to get that anyway, right? So that's sort of your job. Oh crap! It's 99% accurate. That's probably not good. Yeah, there's no upper bound really. That's for better or worse. No, I don't know. That's not a limit. Oh, and what would it do with it anyway, right? You wouldn't want it to stop if it finds something that's 98% accurate. It would show up in there in the leaderboard, and you would say, okay, so this one's probably not a good fit because it's probably subject to overfitting. So I'm not going to use this one. I'm going to use the one that's 90% accurate. So it's going to show you that data anyway. Yes. Oh, interesting. So the question is if it... I would guess that you're going to get the same result. I have no idea. Right, so between different runs, it might vary slightly because there's randomness to how it does the split, which row goes into training, which row goes into evaluation. I haven't really tested that. Well, I've never really run an experiment with the exact same inputs to see if it picks up the exact same level of accuracy and the exact same algorithm. I'll have to try, so I have no idea. That's a good question, though. Yeah, and all the way in the back. So the question is, if I add new data, you're going to have to retrain it all over again. So it doesn't really do any sort of reinforcement learning where so I've got it, and then I'm enhancing it with just a delta of data set. No, you have to start from scratch every single time. But that's not a limitation of this framework. That's just a limitation of you have to retrain from scratch. And your candy, I'm putting it to the side because I don't want to walk all the way back there. And okay. And okay, so there you go. So all 3 of my cluster nodes are added. So now I've got like 24. What's it now? It was 6 times 3, 18 CPUs and or rather cores and like 150 gigabytes of RAM working on it. And let's see how what the results are looking at like right now. So it's running, and okay, and we're 841, which is pretty good. Let's see, the one I trained myself. Let's see. It would be really funny if my really simple example here beat it out. So let's see. And oh, okay, 84.7. So I'm still in the lead, which is surprising. Okay, let's see how this one did. So this is something. Visualize. So this one is at. So the left-hand one is 840. Okay, interesting. So what did I use here? This was logistic regression. There you go. So logistic regression does a really good job on this one. I'll have to keep that in mind. Good. Okay, so that was the hands-on demo on how this works on Azure and their brand new ML service. It's really a good, pretty compelling offering here because it encapsulates everything from so it's it has DevOps capabilities for your machine learning models. It has scalability built in. You can create compute clusters to train your models, and you can very easily take them and productize them and tell, yes, run this model on top of this particular cluster. You can have APIs in front of your models. If you want to commercialize your models, Azure obviously has an API gateway, which gives you all of that billing and rate limiting and authentication and authorization stuff built in. In terms of who the ML service is targeted towards, obviously folks that are new to machine learning and just starting out, because it frees you from having to provision a bunch of virtual machines to execute these tools on, and a visual interface is a lot easier to get started with. Novice data scientists, but also ML experts that are looking for a way to do a quick prototype, right? Right, so just as a sort of a recap, the way you do manual ML right now is you have a data set, you have a model training infrastructure, you try one algorithm, you have one set of parameters, and it produces a model which has an accuracy. You try different parameters, you get a different one, you have a different set of parameters, you get a different one, and you keep going and going and going, which is repetitive and manual, and it sucks. So automated ML is supposed to rescue us from that because we give it an optimization metric, we give it some time and cost constraints, and it goes off there and it works while I talk, which is awesome. Right, so it's much faster and much more accessible. Competition, going back to the question the lady asked over there, yes, a lot, right? So obviously Azure Automated Machine Learning, which is cloud-based and closed source. There's AutoScaLearn, which is open source and is not cloud-based, so you've got to roll it out yourself. Google has an offering in this space. It's called Google AutoML. It's still closed source, and it's got some very interesting features. AutoKeras is another one, and there's a bunch of them out there, right? So it is a very competitive space. If you're looking for something that's really easy to get into, I would say stick to either Microsoft or Google. But if you're really hardcore and intense, you can try on one of the open source ones, but you'd have to stand up a bunch of Kubernetes nodes on your own and deploy certain fairly problematic packages to them. In terms of pricing, so obviously you're going to be on the hook for paying for the virtual machines, right, during training. And during training, that's all you pay for, right? So the framework, for better or worse, is free. So all I'm paying for is however many hours I leave this thing running, times the number of machines, times this price. If you deploy your models to Azure Kubernetes Service, then there is a surcharge of, 4 cents per hour per core, right? So in order because they're giving you, they're relinquishing a lot of, they're taking off of your shoulders a lot of sort of management overhead, they're going to charge you for it. So the total price, so this is not for training, this is for actually running your model once you've trained it. So you would pay the hourly price for the VM plus the machine learning surcharge. This one, for example, has 2 CPUs, so it's 4 cents times 2, and this is the total you would pay per hour per VM. And you can get into really silly situations where, the machine is 1 cent per hour, and the surcharge is 4 cents, right? So because of this really weird pricing model, you're going to want to use slightly larger virtual machines, so you get more bang for your buck. And this is a weird side effect of their pricing model, and I'm hoping they're going to change it, right? Would you want to use Microsoft for this stuff? Well, it depends. Microsoft is still in the visionaries quadrant of the magic quadrant. Their benefit is the fact that they have a really global footprint. So basically, they invest about $1 billion a month in data centers. So if you want to do machine learning in Africa, Azure is one of the, probably the only cloud provider that actually allows you to do that. And for GDPR, it sometimes becomes really important to keep German data in Germany and French data in France. So that can be a factor as well. But in terms of the folks that are in the leaders quadrant, there are a bunch of companies you've never even heard about. TIBCO is somewhat known, but SAS, KNIME, RapidMiner, no idea who those folks are. So it depends. Is AutoML a silver bullet? Somewhat, right? So it helps with model training, tuning, and algorithm development. And if you add these up, you get just shy of 20% of the amount of time that producing machine learning actually consumes. 50% of the time goes to data labeling, but apparently there's people in prison that can do that for you, and data cleansing, right? If you've got, for example, a data set from, I don't know, an e-commerce store, and you've got a field like, a country of origin, a bunch of people are going to be from Azerbaijan, just because that's the first one in the data set, right? A lot of people are going to be accountants, just because that's the very first one in the dropdown, so you have to look at that data and, yank out all of the accountants from Azerbaijan. That will leave you with clean data, so that's what takes up about 20% of the sort of overall project duration for ML. You can start for free. There's a free tier of Azure, and they give you several $100s of credits. If you work for a company that is a Microsoft certified partner, you can get an MSDN subscription through them that gives you $100 and some each month. So there's a lot of ways for you to get started with this without actually paying the money. There's a lot of documentation, in this space, and Microsoft, especially for automated ML, they've put up this distribution list. If you've got questions that I wasn't able to answer or that I didn't answer well enough, you can ask the people that actually built this. The really nice animated slides I copied shamelessly from a Microsoft deck, and the screenshots are from Engadget, The Verge, New York Times, and Stanford News, which happen to be some of the newspapers I read. Thank you to the sponsors and questions. I know we're slightly above time, but I think we're in the break now, so we're probably fine for a few more minutes. Yes? Yeah. Mm-hmm. So the question is if it will tell you why it made the choices it made. Not really. It is transparent in the sense that you can see what it chose, but it's not going to tell you why. I don't think it can actually do that because it's, it is a slightly optimized brute force approach, right? So the one that comes out as the winner is not necessarily, because of this rationale, right? I don't really see how it could tell you why it chose what it chose. I don't believe so. I don't believe so. So you're stuck with whatever it says. So it's transparent in the sense that it will tell you, it will show you exactly what it ran, what hyperparameters, what algorithms, and what the results were, but no, not why that one won. So no. Yes? I don't believe so, no. No, so for IoT scenarios, I don't believe you can really optimize for that. I'd have to check. I mean, I don't really do much with IoT, with edge computing and that sort of thing. So, yeah, no, I don't recall memory footprint threshold being in there though. So I don't believe so. But ask whatever at Microsoft.com. They're going to be much better at doing that, at answering that one, because it's really a specific question. Okay, last question, because I'm really over time. No? Oh, I'm sorry, I wasn't seeing you. Yeah. If I see any opportunities for improvement. Yes, well, mainly the the programmatic retraining of a model. That's a really important feature as well. The visual UI that I showed, so the ML service visual interface is actually crappier than the one they had 5 years ago because it's missing certain components that the other one have. So them getting to feature parity, yeah, there's a lot of improvements, but there's a very sizable team in Microsoft working on this thing. So I'm sure they're going to get there. They are going to catch up eventually. Okay, thank you so much. And so there's one less thing standing between you guys and the weekend. And the UiPath branded backpack goes to you, sir. Thank you so much for all of the excellent questions and keeping me on my toes. I think I still owe the gentleman back there a box of candy.